The goal is to facilitate exchange of data, wherever it may be, whether it's on the cloud, whether it's on the vehicle, should be completely irrelevant. The type of data is, of course, defining what formats and structures and what APIs we're using, but at the end of the day, you will always have a generator and a consumer. We don't aim to define how to do it, but rather we aim to just facilitate it.
The suppliers want to monetize the data, but how do we reach the point of monetization is not really a differentiating point for the OEMs. And this is where standards will come in, because we need to facilitate this link from the car to the cloud.
Welcome to our Point B podcast, where we discuss the future of mobility and transportation products and services. My name is Steve Schwinke, Vice President of Customer Engagement at Sibros, and today we're going to be talking about standards. My guests today are Ben Engel, CTO, and Ahmed, Sadek, Technology Manager at ASAM. ASAM is the Association of Standardization of Automation and Measurement. Welcome, Ben and Ahmed, to our podcast.
Thank you so much. It's a pleasure to be here.
So, Ben, let's just start with you providing the listeners a little bit of background about ASAM and the importance of what you're doing in the mobility space and really driving innovation forward and the future of mobility.
Yeah, I mean, ASAM is a standardization organization. And at first glance, particularly for me, when I first started, I thought, standards boring. But that view very, very rapidly changed as we realized that standards are key. But in all industries, but particularly in this industry that we're in right now. So if we're looking at AD, autonomous driving, highly automated driving, I think everyone by now has come to the realization that the amount of miles that all of us are going to have to drive in order to get the data we need are so high that we can't do it alone. And the only way to get there is to get there together. And standards are sort of the key enabler to allowing people to work together. So that's where we come into play. Our organization is essentially an umbrella that helps different companies in the industry, many companies in the industry, come together to collaborate, to agree on industry standards. So standards that are not mandatory, but standards that help the industry work together. So to facilitate the exchange of data with a focus, of course, on automotive and all of the things that entails. And lately in the last 5 years, of course, a strong focus on standards for autonomous driving, for testing and development of AD.
You're far from really trying to drive commodity. You're trying to drive faster innovation, faster time to market, accelerate the adoption of new technology through standards.
Yeah, spot on. I mean, standardization has really changed from the dry topic it might have been, I think, 20, 30 years ago to a very to reflect maybe the way that the community has shifted in software development as well. So it's very agile, it's very rapid, it's very almost prototypical. I in the past, I called it jokingly research-driven standardization because it's more of an excuse of companies to get together, to work together, to figure out how to do things right, to iterate together on doing it rather than trying and failing by themselves, if you will. So here there's a much higher chance of success because you have even more heads with a much broader spectrum of experience coming together to figure out what is the right way to make sure that what we're doing can guarantee or can provide us some better insights into how safe our vehicles are, how good is the data that we're working with, how good is the understanding of that data. And that's really a paradigm shift in standardization. And that's led to a lot of changes in how we are set up also in how we try to bring people together, how we facilitate this collaboration as well. And that's been a really interesting change to a company over the last years.
So, and it's not just OEMs, right? I mean, it's really OEMs, tier ones coming together to talk about the advancing.
Correct. It's the whole spectrum from OEMs all the way across the supplier chain to tier ones and over the last years, even further down on the chain. So we're really seeing the chip industry is becoming involved in topics where maybe in the past they weren't as involved, and that's really changing. But also to the academic areas as well. So a lot of links to research institutes where, of course, you also have the OEMs, but a lot of research institutes, academic institutes that are also participating.
I think about it in the past. The past is big barrier to entry, right? Internal combustion engines, there was only room for 4, 5, 6, 7 companies out there that really had already made that investment to kind of build cars and trucks but now we see the emergence of new age OEMs coming into the space, and I think part of it has to do with EV technology. It's much simpler technology to deploy. They can innovate on a few areas, but it's also important for them to adapt standards, right? And so, guide us through what's the process of kind of bringing these standards into an organization, and how are you attracting these new age companies? They're popping up all over the place in terms of building new mobility products. How are you getting them interested in participating in ASAM?
I'll answer that question in a second. I actually have a comment on that. Because you called them new age OEMs, I think that's a very important observation, actually. And that's causing, I mentioned paradigm shift, but that's causing maybe even friction, if you will, in the industry, because there's a lot of discussions on what's the best way forward. And of course, the large established OEMs have a way they've always been doing things, right? And then you have these new kids on the block that come in with completely different mindsets to how to do things, maybe less legacy, less experience, certainly, but they also, I mentioned the chip industry as one example, but you also see the software industry was playing a much stronger role, and you see a shift in the OEMs to adopt some of these, on the one hand, some of these resources, but on the other hand, some of the methodologies as well. And that leads to some really interesting discussions when they all come together in standardization, because that's where they're trying to figure out, how do we exchange and what's the best approach. And an interesting example is sort of the scenario-based testing that's evolved over the last years to really become a big, important, or critical part of the V&V cycle when it comes to testing for ADAS. And there is a lot of friction on just in this part. How do we best simulate scenarios? How do we set up scenarios? How do we describe them? What is the role of simulation as a whole in testing? And that's really starting to proliferate from, I think, these new age OEMs all the way across the spectrum. And that's really interesting to observe. And I think that's what we see, of course, in the fact that simulation is playing such a big role overall. So I took a slight detour on that, but maybe back to your original question. We have a pretty easy job, if you will, in the industry right now, because, like I said, everyone sees a clear need to have to work together in the industry. And as long as we make working under and in the ASAM community a relatively frictionless experience, a pleasant experience, right, then it's sort of a given. One example we have in China, of course, for many Chinese OEMs, for them it's particularly interesting to have access to the wider international market, ignoring all of the politics. I think this is a very important aspect that's really leading to the proliferation of our standards in the Chinese market as well. So it's globalization, if you will, maybe at a slightly different scale, but that is sort of the key argument, I think, for why our standards are becoming so well used. And because of the fact that they are developed so agile, so fast, so rapidly to meet the continuously growing demands of the industry, I think that's something that is sort of an argument for itself, right?
Yeah, I like that. The argument here is not about, slowing down because there's so many standards to worry about. It's about accelerating, companies and
Exactly.
giving them a broader reach into different areas and solving problems together, but then still allowing them to differentiate their product. So I can see the value that comes from it. Ahmed, I want to bring you into this conversation a little bit. Can you tell me about your role and how long you've been with ASAM and what's exciting you about the industry right now?
Well, I could start a bit earlier, but before my role. So I come more from a hardcore development background, let's put it like that, more into function development and algorithm development for autonomous driving. And the shift from moving to pure software development, let's put it like that, into doing standards was a bit shock at the beginning for me. Like, what are standards? What are actually these solutions? Like, why do we actually do standards? And then when I start reading more and going back into my 6 years of development, I start seeing that I have been already using standards for a long time to resolve a lot of problems. And as a surprise for me, that came that ASAM standards, I have been using them for years. Something like the MCD standards, like A12 description files, XCP standards. I was surprised that they were actually ASAM standards. And maybe that's a lack of research from my side at that point. But then I realized that how these solutions are actually uh, facilitating the whole development process. You're not going to reinvent the wheel. Let's put it like that when you're developing. So it's more useful to get the state of the art of the industry. Don't reinvent solutions again for solve problems. And that's what got me motivated to do standards more. And to be honest, also at the point that Ben mentioned, how dynamic the working groups are, I have learned in some aspects that I haven't touched before in testing and validation and simulation driven. Just by joining these groups, I have learned more about the industry than years in actually working in development. So you can imagine that just this dynamic of discussion with a lot of parties, you can see a lot of other views of how the problems are being solved, not only whatever entity you are sitting in, whether you're OEM or a tier one or a tool provider. No, you start to seeing the whole big picture from all the other parts. And that's what really exciting in working in standards.
And so what you're doing is sharing information to kind of make sure that safer roads, safer driving, just better understanding of road conditions, right? And how you simulate that automated driving, as well as probably provide opportunities for more companies to participate in the advancement towards autonomous driving.
To put it frankly, I mean, for sure, right? I think one thing that's important, I think, to mention also, there's, and maybe I'll come back to that in a second. The software-defined vehicle. Ahmed, you mentioned the shift to the software-driven or the software-defined, if you will, topic, and that's of course a very important buzzword almost in the industry right now, right? But it's important also that the industry is very mature in certain other aspects, and now we need to look at how that experience can come together, right? And we have a large portfolio of mature standards, of course, so they play a very strong role in this when it comes to test automation and diagnostics. But again, the challenge now is seeing how this mature, very proliferated portfolio of standards fits together with all of these new kids on the block: simulation, software-defined vehicle, right? And for us, sort of, to talk about the software-defined vehicle is, I like the hype around it, and there is a clear reason for it, of course. But at the end of the day, software has been in vehicles for many years now, and it's not necessarily a new concept. And that is sort of the key of our argument as well. We say for us, software is nothing new. There's more software. There's exponentially more software. HPCs are, of course, a topic that wasn't relevant a couple of years ago, a couple of decades ago. And so we need to look at how this more has what implications that has. And I think that opens up some discussions that maybe were not possible in the past. Even looking at the diagnostics side, vehicle diagnostics before we had the compute on board, it was very limited by the availability of the hardware, and that's changing, and it allows us to decouple from the hardware much more, which means this paradigm to the software-defined vehicle on the one hand is driven, of course, by stronger hardware, which means we have better software. We can put more software on there, which means we can even decouple the development of software from the hardware, which means, and that's the main enabler for allowing us to talk about developing software for the vehicle and all the implications that has, whether it's over the air or increased diagnostics capabilities or increased autonomous functionality, right? The use cases are extremely interesting, and at the end, at the core of it all, we have, of course, the over-the-air side of things, right? We need to be able to talk over the air. There's security considerations that play a huge role that maybe didn't play a role at all in the past. So this is where we really are very strongly invested in trying to understand what implications this has, And we see that in the industry right now with a plethora of different consortia that are working on this topic right now, right? And Ahmed, you're sort of very much in the loop of this, right? And maybe you can give us a bit of a rundown sort of on your thoughts where ASAM and all of these other things fit together, and then we can dive from there, maybe.
Exactly, as you said, like software-defined vehicles is a buzzword, but I would see it like as just the natural evolution of how the vehicle is moving on and on. So once we started introducing high-speed connectivity to the car, the amount of data that is generated from the car exploded exponentially. And it's not only the amount. The problem is now having several aspects. So it's what data are you trying to collect? When are you trying to collect them? And where are you going to store and sort them and how to do that? And if you look at this problem of the data, it's not really the value generating for the OEM or the suppliers. The suppliers want to monetize the data, but how do we reach the point of monetization is not really a differentiating point for the OEMs. And this is where standards will come in, because we try to facilitate this technical area that is not generating value for OEMs or for the tech companies or even software providers who can work after or using the OEM data. We need to facilitate this link from the car to the cloud.
Let me go into this a little bit more deeper, because this is a fascinating topic in terms of software-defined vehicle. You're working on a standard called SOVD, Service-Oriented Vehicle Diagnostics, right? Can you tell me a little bit more about SOVD, the work that you're doing in that area, and what, some of the goals that you're trying to accomplish?
Exactly. So SOVD, as the name is saying, Service-Oriented Vehicle Diagnostic. This is the name of the standard. And as you can see, the first part, the service-oriented part, this is where SOVD, why it was developed. So we're moving from monolithic architecture for the software. So a software, an ECU that's having a single functionality, let's put it like that, into an HPC that have a lot of services that are running on the car. So the mentality of how are you going to deal with this architecture is different, and this is where SOVD started to get implemented. We need a different mechanism of collecting diagnostics. We need a different mechanism for defining what data of diagnostics are we going to collect, and eventually we are introducing even more complex use cases, such as remote diagnostics, to serve other purposes such as the fleet management or predictive maintenance. So now we look at data as a source that is generating the data, and then there is a consumer. Where is the consumer located should not be relevant, whether it's on the car, whether it's on the cloud. That shouldn't be relevant.
But you mentioned one important point, I think, right? And that's the source sync approach. And for us, there is, like I mentioned before, with a wide array of different consortia in the industry that are working on this topic right now. Yeah? To name a few, you have the SOFI consortium, the Eclipse STV, you have Autosar, you have Coves, the list goes on and on and on. Sure. And the common ground amongst all of these is the definition of some sort of less monolithic architecture for the software-defined vehicle. And we decided our role as a standardization organization is not to do just another architecture, that doesn't help, right? Adding just another standard on top doesn't really benefit anybody. And that's where this source sync approach comes in. Our goal is to, independent of which architecture we are, so we're aiming to be architecture agnostic, the goal is to facilitate exchange of data, wherever it may be, whether it's on the cloud, whether it's on the vehicle, should be completely irrelevant. The type of data is, of course, defining what formats and structures and what APIs we're using. But at the end of the day, you will always have a generator and a consumer, whether we're looking at sensor data, measurement data, whatever else. They're stored in some form. They're communicated via some API or protocol, and they're stored somewhere and retrieved by something. And with this approach, our goal is to then dock on to basically the other parties out there, to collaborate with them and show how this completes the picture, if you will. because we don't aim to define how to do it, because that's not our core expertise, but rather we aim to just facilitate it. And I think that's what we do best. And for the software-defined vehicle, this shift to all of these different software stacks, the very wide array of different software stacks, just means that there's even more for us to do, because there's even more interfaces we have to look at.
We have this shift left mentality in the industry, right? More virtualization. And then we move that software development from the cloud to these HPCs. These HPCs now have multiple roles where they traditionally have been multiple ECUs. But SOVD means that the data comes with a description of the data. So we can service these vehicles better. We can get better insights into these vehicles. We can interpret the data faster. It's all around acceleration.
I could jump a bit deeper in the technicalities. So how did we used to do diagnostics, and how is OVD is trying to do diagnostics? So the approach for classical ECUs, and classical ECUs here, I mean the ECUs that were based on microcontrollers, is that we have a definition of the diagnostics data saved in classically an ODX file. And this ODX file is being read by whatever tool the maintenance or the engineer are trying to access the diagnostic data from the car through an OBD or whatever. With the service-oriented architecture and with continuous updates, this ODX needs to be updated all the time. And that means that the OEM needs to supply this ODX back again to the maintenance centers. We need to go into a bigger loop of communication all the time. And this is something that SOVD is solving by having a dynamic capability description. Basically, at the beginning, the OEM will define those data in this capability description that is going to be on the car side of SOVD. And then when there is an update or something, then the capability description can be accessed and read again from the client side, which can be, in this case, the maintenance person or the remote support and a remote use case. And we get out of this loop that we can update the car independently of resharing these information again and again and again on the maintenance side. This is one capability that or a use case that was really considered in designing the SOVD specifications that serves eventually the software-defined vehicle.
That is a great description. At Sibros, our first customer that requested us to provide SOVD compatibility, we looked at it and we said, well, this fits perfectly with kind of our approach, which is a product-based approach to building OTA and data logging solution for our customers. So our work to get there really just required us to put on the API definitions within the SOVD. So, to me, this becomes this product-based approach for diagnostics, and it fit very well with our company approach to doing diagnostic and getting the information. So not only can we deliver updates to the vehicle, but we have this opportunity to kind of collect data from the vehicle. That's why I think we're here talking, because our interests are aligned in terms of what your approach is, what our approach is to kind of accelerate companies and let them to differentiate on products and services, but maybe solve some of the bigger problems collectively as an industry to help everyone out.
No, I fully agree. And I think that was the intent, right? I mean, it's always sort of a balance when it comes to standards to try to find something that's suitable for a large majority without being too big that you sort of shoot yourself in the foot because it's so bloated that, right? But I think the advantage of the approach that SOVD takes is this REST-based approach, and the fact that it allows OEMs the flexibility to define what data they make available over this API. So which endpoints do they expose, rather than having that prescribed by the standard, makes it much more flexible, because otherwise I think we would have done exactly that, namely shoot ourselves in the foot, because there is a very wide difference amongst the OEMs on what information they do make available, whether it's for diagnostics or anything else, right? That for them, a lot of that is is proprietary. They don't like, understandably, to make that available. And I think that flexibility is sort of the key tenet for a standard that has the potential to be successful, right?
And it evolves, right? The SOVD is a dynamic. It'll never be done, right? I like saying those types of things because things will evolve. And so the goal is to make sure that the standard evolves as the industry evolves.
I mean, a big topic right now is legal diagnostics that they're discussing, right? So the first version of SOVD was released last year and is currently in the process of also being transferred to ISO to allow it to be integrated into, or potentially integrated, or hopefully integrated into regulation, because of course of the reach and the, let's say, the standing that ISO has in the industry, right? There's two differentiators that we have between these two organizations, right? So we work very close. Slight tangent, but we'll come back. ISO and ASAM are complementary in the sense that we don't compete most of the time on the types of standards that are developed. At ISO, they're developing best practices, processes, things like this, and ours are close to the implementation level. But we, by nature of our size and the way we're set up, are much, much faster than ISO, which is an advantage when it comes to development, especially for immature topics that need to grow a bit and iterate before a certain level of maturity is reached. Whereas ISO, of course, by its nature, is slower, but also thereby has a stronger reach when it comes to integration to regulation, right? You can't add a standard that changes every year to regulation because that causes problems. And that's how ISO's processes are set up. And this is how we collaborate on many of our standards in the past, where member companies leverage the speed and the processes in ASAM to develop fast, maybe. And then if there's an interest in regulation, in sort of maybe stamping something a little bit more formally in stone or something softer, then transferring it to ISO. And that's what's happening with SOVD right now. So the first version is expected to be in the final phase at ISO beginning of next year. And there will also be considerations added for legal diagnostics. And I think that's a very strong interest right now in the industry when it comes to how do we do it and how do we support it. Right? And I think that's where SOVD should provide some answers.
Let me get into ASAM a little bit more. I feel like collaboration also involves, compromise, but there's also resistance. So I think there's two parts to this. I think you're smiling here, but resistance is going to be, just people that don't want the standard that's out there. This is the way they've always done it. But then there is also conflict where two different approaches, run into each other. Tell me more about the conflict resolution that takes place within these working groups. I mean, are they basically work it out, or do they need adult supervision every once in a while?
So sometimes they need adult supervision, which is why Ahmed and other technology managers are there, right? They're the ones that pull them apart when it gets of course. There are enough examples in the past where companies have a clear commercial interest to be the only ones that have the interfaces that they have. They don't want to open the market, and that's clear from a commercial standpoint. So that will always happen. Yeah, but at the end of the day, if there's enough industry impetus to try to come up with a joint solution, most of the time, my experience is that these companies then at some point do end up, joining the fold, if you will. That it's not always a success story. There are often examples where a standard is released by too small a subset of the industry, and the other industry decides to go a different way. And that's the disadvantage with optional standards, if you will. You don't have to use them if you don't need them. And best example, Blu-ray back in the early 2000s, right? There were a lot of other options, and not all of them won, right? Or USB is another example for charging solutions. So just because it's a standard doesn't mean it's the best solution or it's the only solution. But at the end of the day, we as ASAM try to make sure we get enough industry representation so that we can gauge the relevance in the industry as a whole, and so that we can reach a critical mass so that you have enough stakeholders involved. And this is a challenge, especially with all the new players. So you really have to make sure you get the new kids on the block, that you get you get representation by the old horses, the OEMs, right, across the spectrum, to make sure that you have enough people at the table to actually have a discussion that has weight. And that's a big part of what we in our role try to do, right, when a standard gets proposed. So there are rules and processes in place to try to support that. But at the end of the day, that's sort of part of our daily business.
So Ahmed, sometimes there's just the right decision. There's intuitively obvious solutions that, people will still want to go their own way. But at the end of the day, it's kind of your job to say, this is probably the best thing for our industry.
Yeah, we always have to stay back and let them fight first, and then we just join the winning side. No, but as an office, we should stay neutral. This is very important for us. Just to keep always the members. They are the ones who make the decision. They are the ones who engage in how the standard is written and which technology is being used. All of those design decisions that go into the standard are member-based. But our role is keep it on time, keep the delivery. All the commitments that were made at the beginning of the proposal should be done on time. And if it needs an extension or needs something, we have to argue that with our technical steering committee. Again, the conflict resolution is, of course, part of our daily job. It's usually not that bad, but yeah, that's the type of the position. So
sure,
we just have to live with that.
We have a very good understanding of the big picture when it comes to the technical status, the cutting edge of topics. And that helps because it allows us to bridge the gap between companies. So if we use SOVD as a current example, there are other solutions out there that are being developed in parallel. And our aim, of course, is to reduce redundancy. And if we identify such, either because we stumble on them or because members do and bring it to our attention, we try to bring these communities together. So if we look, the current example we have actually with SOVD is at AUTOSAR. There is an API that's also being developed called the Automotive API. And we were recently in discussions with the AUTOSAR management to try to figure out how to bring the stakeholders together so they can discuss and at least align a little bit on the use cases, the boundaries, and the motivation, so that we can try overall to provide some clarity to the industry. Why are they out there? What's the differences, to help the industry make a decision if for one or the other, if you will, or at least to understand better before they make a decision.
The right technology prevails. It's getting to that point can be a little bit painful, getting people to agree, because it's based on kind of what's behind the scenes, what's motivating them.
Even at the standards, the organization level, what we see, at the beginning, I started with the chip industry as one example, but telecommunications that are essentially, that's another big topic right now, right? If we look at, we have organizations like 5GAA that in the past maybe were not so actively involved in automotive driven discussions, and now with this whole onset of V2X, suddenly we need to talk to them, we need to have them involved. So there's lots of silos in the industry. Another example, off-road, right? There's a strong difference between the companies that are developing, or the departments in companies that are developing for on-road versus off-road, where we have a lot of use cases that are probably going to be autonomous or more autonomous much earlier. So we're looking at how we can take these lessons to bridge the gap over there. So how can we take the lessons learned in on-road and show what we do there and bring it into agriculture, construction, autonomous logistics. Harbor is a big topic right now, for example. And there are a lot of overlaps.
You touched on 5GAA is extremely important, especially around automotive safety, things that you can do with 5G technology. The standards are evolving, but not everyone's adopting them as fast as necessary in order for, I always like to think that perception systems are very expensive. So why doesn't everyone just broadcast what they're doing, and make the discovery for autonomous vehicles that much easier and that much more certain, right, in terms of what's going on? But I think we're a ways away from that. But these are the things that standards can do, as long as they're the right standard and we get the right adoption of that technology across the industries. I think what we're going to do is see that acceleration of products, services, and really just building a future that we all want to live in, but that much faster. I want to thank you both for being my guests today. But before you go, I got one rapid fire question for you. And then Ben, I'm going to ask you the exact same thing. You're in a autonomous vehicle without a safety driver. What's the top speed you're willing to go?
Well, living in Germany with the Autobahn with unlimited speed, yeah, I just wanted a 300 kph at least.
Oh, you're going all that way, even no one behind the wheel.
Let me give you an example like previously. So we were doing a demo for a parking function, and we took the car, we set it outside of a conference. We planned the trip that the members of or the participants of the conference will get out. We'll ride in the car. We have our representative. He will explain how the parking function is moving, and then the car is moving around something like we had a limit of 5 kph to move around this parking lot. I, as the developer, of course, I don't trust it because it's a very early phase of the function. Our representative, who was inside the car explaining how the function is working, was also our safety driver. At the beginning of the demoing with the conference members, he was very attentive. He was always having his hands ready to stop the car at any moment. After maybe the 5th or 6th trial, he started to trust the car more and more and more, that he started to stay not looking at the road, not looking at where is the car moving. And then I started to put my hands on my heart and push the push button that I have externally outside the car ready. So you will be surprised of how people will start trusting the autonomous driving features once they start roll out, and they will be happy to take risks on that. So 300 kph is not that far, I would say.
Okay. How about you, Ben?
I have a much more conservative view at the moment. I think trust is very hard to gain once broken. Right? And gaining trust is easy, but when you lose it, it's hard to get it back again. And that's why, for me, that is a very cautious decision that needs to be made. Knowing what I know of the industry's development state at the moment, I wouldn't feel safe in an autonomous car. That's there are some shuttles that are probably going up to 10 to 20 kph that I might sit in, but knowing what I know of the ODDs that you have and how quickly they can change and how difficult it is to describe them sufficiently so far today, I'm very comfortable with talking about sitting in an autonomous tractor on a field somewhere or on a construction site, but take me off and I'd feel nervous.
All right, that is all the time we have. Ahmed, and I want to thank you so much for joining me today to talk about the very important work that you're doing with ASAM. And I want to applaud your efforts to really kind of contributing to the acceleration, getting companies to accelerate new forms of mobility and really helping build solutions that we're all going to take advantage of. So thank you for joining me today on Point B.
Thank you, Steve.
Thank you too.
Much appreciated. It was a pleasure.